Good morning or afternoon. Just a quick review of Slope Dude. I hope you all have this glued in your notebook. But moving west to east or left to right, if the line is heading uphill, it's puff, puff, positive. Heading downhill, it's nice, negative. This is zero fun. Very flat line, hard to ski on flat surfaces. And then the curse word of all algebra, undefined. Today we're going to actually be putting some lines on a graph, looking closely at the direction the line travels. So I just wanted to refresh your memory on that. On the piece of paper you should have two grids. Mine is a little bit bigger than yours. But whatever I write, once again, I would like you to write down. I'm going to give you two ordered pairs. The first ordered pair is -2, 4. The second ordered pair that I want you to graph is 3, -2. Just a friendly reminder, we will start at the origin. Remember, sometimes I put a box where the origin is. Because this one's negative, we go left 2, turn, and go up 4, and that is 1 point on the graph. Each number is not a point on the graph. Go back to your starting point, 3 to the right because it's positive, and 2 down because the y is negative. Doing the best you can. Please draw a straight line that passes through these 2 points. I'm cheating because I have like a straight edge here. You don't need a straight edge. Just do the best you can. Remember, if you move your whole arm, your line tends to be straighter. All right, first thing I always like to do is I like to look at the line. Left to right, or west to east. What direction is the line traveling? It is traveling downhill, so I could draw my little Slope Dude. There's his legs. Looks like he's going down on one of those saucers, but he is headed downhill. So something I know right away, my slope, the direction of my line, if there was a story problem, it would be the unit rate, is negative. We have to remember that that is very, very key. It is negative. Now that we're going to try to figure out how steep is this line, how fast is Slope Dude headed down the hill, what we're going to do is we're going to connect these two ordered pairs. These are good points on the graph. I'll go into more detail with that in just a moment. This time we're going to connect them with a right triangle, but I'm going to go above the line. Does it matter if you go with your triangle above or below the line? No, it does not matter. It just needs to make a right triangle connecting these 2 points. So take a minute. I made mine a little thicker so that hopefully with the camera you can see my line. Okay. Now another question before we do anything else is I have asked you in the past, what are we counting by? Remember how we would count our rows tall? We have to figure out what we're counting by. Few ways we can do it. I can see here we're counting by ones. We're counting by ones. I need to figure out how tall is this. This is the change in the y. So we need to find change in y's. And the y's are the up and down when you are graphing. I just like to count my rows. I tend to put dots in my rows as I go. So I have 1, 2, 3, 4, 5, 6. I have a change of 6. My y's are changing by 6. I could see that if I wanted to look here, this one starts at -2 and it goes to 4 on a number line. -2 is 6 digits away from 4. Then we will turn the corner and we need to find the change in the x's. That's the left and right. How did the x's change? Again, I just 1, 2, 3, 4, 5. They changed by 5. I can see that this point is at -2. This is at 3. They are 5 digits apart on a number line. Okay, we cannot reduce this fraction. You will always leave it top heavy. But remember, we talked about the slope is headed downhill when you look at it left to right. Therefore, we need to make sure to include the negative sign. So this line is changing at a rate of -6/5. That is how you can find the steepness of a line or how something is changing when you're looking at a graph. If I didn't give you a graph and I didn't give you a table and I said, find the rate of change, find the unit rate given these two ordered pairs, what I would do is just make a t-chart. I would write the ordered pairs. The first ordered pair was -2, 4. The second ordered pair was 3, -2. Oh, now we have created a table. We ask ourselves, how did these two numbers change? To go from here to here, I must have added 5. There are 5 numbers apart on a calculator. I knew it was positive because we went from -2 to 3. We're going from +4 to -2, so that's subtraction. 4 minus what will get me to -2? -6. So again, it is the change in y over the change in x. That plus sign is optional, but you will see that we have the same solution. All right, that was a lot of information. I usually put my pause card here because what I do want you to do is just pause the video. I'll move the card. I want to make sure your paper looks like mine. Please pause the video a moment. Thank you for pausing. I even pause at home. Not real sure why I do that, but I do that. Okay, you were given another graph. So I'm just going to move my paper. You don't have to really do much to yours. I'm going to give you two ordered pairs again. I will give you the ordered pair 2, 4 and the ordered pair -2, -4. Remember, that is your starting point. I'll give you 15 seconds or so. Please graph those two ordered pairs on your graph. Connect them with the best straight line that you can. Make sure your line and my line look identical. So I started at the origin. I went right to up 4 for the first one. The second one, I went left to down 4. Again, doing the best you can to make a straight line. You don't have to have a straight edge. I just try to do that so that I make sure things look good for you. Okay, I want to first talk about moving left to right on the graph. If I start on the left part of the graph and trace my finger on the line, what do you notice? What direction did my finger travel? It traveled uphill. Well, what is Slope Dude doing if we travel uphill? He's down here and he's singing puff, puff, positive. That's a very steep line. So for our slope, our rate of change, we know our answer needs to be positive. It is headed uphill. Excellent. Just like we did last time, we are going to connect these 2 points with a right triangle. This time, just to show you it doesn't matter, I'm going to connect them below the line. So here we go. Ooh, my ink pen is dying. I'm just making my lines a little darker so that you can see them. I have created a right triangle. We need to ask ourselves, what did I count by? I counted by ones here, and I counted by ones here. Wonderful. We're going to start with the change in y's. How tall is this triangle we made? How tall is it? Well, 1, 2, 3, 4, 5, 6, 7, 8. It is 8 rows tall. Then I turn and I want to see the change in x's. What I'm really asking is, how wide is that triangle? From here to here, how wide is the triangle? 1, 2, 3, 4. It is 4 wide. Height and the width. Okay. Oh, it looks like then we can simplify this fraction. 8 divided by 4, remember it is always the top divided by the bottom, I would get 2. And you may write 2 over 1 or simply 2. It's positive, so you can put a plus sign, but completely not necessary. Okay. If I didn't give you a graph, I just gave you those 2 ordered pairs, and I asked you to find the height, find the slope. How steep is this line? You could change it into a table. We've been practicing tables. We know how to do that. You can write the ordered pair to 4, -2, -4. Now we need to figure out how do they change from one row to the other. To go from here to here, 2 to -2, the numbers are getting smaller, so I know it's subtraction. 2 minus what gets you -2? -4. Then I'll look at this one. 4 to -4 is negative, so I know 4 minus what gets you -4? -8. Again, the change in y's, -8, over the change in the x's, -4. Negative divided by negative is positive. 8 divided by 4 is 2. Oh, what do you know? We got the same answer. Again, please pause the video right here if you need to. Make sure your paper looks just like mine. We will add stories and content and things like that to the graph to help make it more sense. Pause the video, please.